So today I'm here with lecture 2 of chapter 3, right? In this lecture, I'm going to discuss a mechanism of current flow in conductor, right? Okay, so mechanism basically we are going to study. Suppose current is flowing inside the conductor, so what is happening inside the conductor? Those things we are going to study, right? Okay, so this is your conductor, okay, and in this conductor many electron is present, right? Okay, so inside this conductor many electron is present. Suppose these are the electron, right? And all the electron is in random motion, right? All the electron is in random motion. Okay, so electron is moving in random direction, right? So you can see these are this dotted is the electron and this arrow is showing the direction of motion of electron, right? So electron is moving randomly in all direction, right? So in absence of electric field here no battery is connected through the conductor, okay? So here battery is not connected, so electron is in random motion, right? Random motion, that means suppose if I am going to consider an area, suppose I am going to consider an area here, right? Suppose I am going to consider an area here, right? So electron is in random motion, right? So number of electron going to that side is equal to number of electron coming to this side, right? So suppose I am going to calculate net charge, how much charge is crossing this one, right? So as electron is in random motion, right? So if 5 electron will come to this side, right? Then 5 electron will also go to that side, right? So suppose 5 electron is came to this side, right? So I got charge 5e, because you know charge on electron is E, right? And 5 electron is went to that side. So if I'm taking this side as a positive, right? So other side will be negative side, right? So that charge will be how much? 5e, right? So now you can see net charge crossing to this one will be 0, because 5e 0, right? So net charge crossing in this one is 0, right? So current will be 0, right? Because you know current is equal to Q by T, right? And Q is 0, so current will be 0, right? So that means if there is no battery connected across this one, right? If no battery is connected, that means number of electron crossing going to that side is equal to number of electron coming to this side, right? Okay, so now, so electron is in random motion, right? Random motion, and all electron is moving with different velocity. Suppose this is your first electron, right? And first electron is moving with u1, right? And suppose this is your second electron, right? And second electron is moving with u2, right? So similarly n number of electron is present, right? And this is your nth electron, right? And nth electron is moving with, so see, these are the random motion, right? So average velocity of electron will be 0, right? So I wrote everything here, right? So just you copy down it, and then here we can write V average, right? V average of electron will be 0, right? Because electron is in random motion, right? Okay, so further we can write here U1 average. Average, you know how to calculate average? Sum of all velocity divided by number of electron, right? So sum of all velocity, first one is having u1 velocity, second one is having u2 velocity, right? And third one is having u3. Many charge particle is present, right? Dot plus un. Un is velocity of n charge, right? Nth electron divided by n number of velocity, right? Divided by n, and sum will be 0, right? So average velocity is how much, came? Average velocity is 0, right? Okay, now, so if there is no electron, if no battery is connected, right? You can see here battery is not connected, right? If battery is not connected, so electron is in random motion, right? Electron is in random motion, right? So charge crossing to this area, net charge crossing to this area will be 0, so electric current will be 0, right? And now suppose I'm going to apply battery, right? So I connected the battery, okay? So as I connected the battery, and this battery is having potential V, length of conductor is L, right? So this is positive terminal, so this one is at higher potential and this is at lower potential, right? Low potential, okay? So again there will be electric field, okay? And that electric field is how much? V by electric field is how much? V by L. V by L is electric field, right? Okay. So initially there was no electric field, right? No electric field, and now electric field is established inside the conductor, right? Okay. So now what going to happen here? So this is your electron, right? Right now electron is also in this one, electron is also in a random motion, right? But along with random motion, electron will acquire some speed, some velocity, right? Why will electron will acquire some velocity? Because due to this electric field, right? Electric field is present. So right now also electron is in random motion, right? So electron is in random motion. So electron is colliding with lattice, okay? So electron is colliding. So random motion is happening inside the conductor, right? So but due to battery there will be electric field. Due to electric field, electron will get some additional velocity, right? Velocity will come due to electric field, right? Now you know electric field, due to that electric field there will be force on the electron, right? Okay. So in this electric field, each free electron starts experiencing electric force, right? Given by minus of E into E, and that force is how much? This much, right? So suppose in this direction electric field is established how much? E, right? So force on electron will be how much? Suppose this is your electron, right? Right, and force will be how much? Fe, right? And F is this much, right? Now, so initially it was in random motion, right? Right now electron is also in random motion, right? But due to this one, apart from random motion, electron will acquire some speed, right? Why will acquire some speed, right? Speed will increase or velocity will increase, right? Why velocity will increase? Due to force, right? And force will create acceleration, okay? Yes. So note it down up to this, okay? Next we are going to write acceleration of electron, right? So now see, force is acting on electron, right? So there will be acceleration of each electron, right? So we can write hence acceleration of each electron, hence is acceleration of each electron is equal to, you know, acceleration is equal to force by m, right? And this m is what? Mass of electron, right? And this, now further we can write F is having how much value? Minus E F by m, right? Now you can see here, initially when there were no batteries connected, so first electron is having how much velocity? U1, right? But now acceleration, due to acceleration velocity will increase, yes or no, right? So now we can write here, okay, yeah, here E will come, right? If T1 is the time interval, if T1 is the time interval, if T1 is the time interval for which electrons moves freely, the velocity, okay? So if T1 is the time interval for which electron moves freely, right? So moves freely means as electron is moving inside the conductor, no? So electron is colliding with other electron as well as lattice of your element, right? Ion, we can say like that, no? Suppose this is your atom, right? So atom has what? Electron as well as positive charge, right? So electron is moving but positive charge is present here, no? Positive charge means nucleus is present, right? So due to that one colliding with nucleus, right? So due to that collision, velocity due to that collision, again velocity is becoming 0, right? And it will move, again velocity will become like this, okay? And again due to acceleration it will start acquiring some velocity, right? So here we can say if t1 is the time interval for which electron moves freely, right? For time t interval electron moves freely, right? Okay, so velocity acquired will be how much? You know, velocity is equal to final velocity equals to u plus at. You know this one, right? So final velocity acquired by first electron will be how much? v1 is equal to u1 plus a into t1, right? Similarly we can write also for other similarly we can write v2 is equal to a2 into t2 because collision, because second electron is having how much collision, how much time interval of collision? t2, right? First one is having how much time interval of collision? t1, right? Okay, so similarly we can say for third electron u3, right? And a vector t3 dot 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 we can write vn, and v1 is equal to un plus a. So these are the final velocity acquired by electron, right, in electric field, right? Okay, so again we are going to calculate ratio of this one, right? Again we are going to calculate average of final speed, right? So average of final speed, so again we have to rub this part. So here we can write on an average velocity acquired by electron, on an average velocity acquired by electron is v average, right? And that v average will be mean of this one, right? So we can write v1 plus v2 plus v3, okay, plus dot 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 plus vn is equal divided by n, right? Okay, so now v1 is having this much velocity, okay, so we have to substitute that one. So in place of v1 we can write u1 plus a vector t1, right? And v2 is equal to u a2, okay, plus v3 is u3 plus, sorry, we have to put vector here, a and t3. Similarly dot 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 for n, what is the for nth un a and a vector into tn divided by n, because we are calculating average, right? So average is equal to sum of all the velocity divided by number of electron, right? And is the number of electron, right? So further I'm going to rearrange it, okay? So see, further we can write it u1 plus u2 plus u3 plus un plus dot 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 un divided by n. And see here a is present everywhere now, right? So we can take a as a common, and so inside the bracket we have t1 plus t2 plus t3 plus dot 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 tn divided by n, right? You know this value is 0, right? So here we can write 0 plus a. See, this is the average time of collision, right? Average time of collision. So, and this one is known as relaxation time, right? Relaxation time, and this is represented by tau, right? So we can write here where tau is relaxation time, or average time of collision, or average time of collision of electron, right? So, and further we can write v average. V average is equal to a tau, right? And a is having how much value? You know value of a, right? And that a is how much? This a is acceleration, right? and you know acceleration we already calculated, right? And acceleration is how much here? Acceleration is minus E by me. You know this one, right? This is acceleration of electron, so we can substitute this value here, right? So minus by me into tau, right? So finally I got this formula, right? See, this average velocity is known as drift velocity, right? Drift velocity. This average velocity is known as drift velocity or drift speed, right? Sometimes we call it drift speed, right? Drift speed, and this is represented by Vd. This is represented by Vd, okay? So further we can write Vd is equal to minus E by me into tau, right? So this formula you have to remember. Drift velocity is equal to this one, right? Okay. E is the electric field, m is the mass of electron, right? And E is the charge on electron, and tau is relaxation time, right? Relaxation time is depend on the material. Suppose if you are going to take iron, right? So relaxation time will be different, right? For copper, for different material, this value will be different, right? Okay. So note it down up to this. And further, if you going to write this one in only in magnitude form, right? So only magnitude. What value you can write? UE tau by m. Here we are taking direction also, right? Here drift velocity is in vector form, right? So if you are going to write in only magnitude, so you can write like this, okay? So I hope you have written all these things, right? So now I am going to rub this one. So in this one, mechanism of current flow, we have calculated drift velocity, right? So in next we are going to discuss relation between current and drift velocity, right? I have to rub it, okay? Now we are going to discuss relation between electric current and drift velocity, right? So what is the relation between that one? So I took a conductor. So this is your conductor, right? And conductor is having cross section area. Suppose this is your conductor, right? And cross section area of conductor is A. I have also written this one here. And charge on one electron is electric charge. That is how much? E, right? One electron, how much charge? E. And current is passing through. This one is I, okay? And so due to this current, electron will moving with drift speed, right? Okay? And in this conductor is having n number of electron in per unit volume, right? So n number of electron per unit volume, right? Here n is number of electron per unit volume, right? So this one is connected to battery, right? Current is flowing now. Current is flowing. That means it is connected through battery, right? So electron is moving with drift speed, right? Drift velocity, right? So suppose one electron is present here, right? Suppose one electron is present here, right? Okay. So this electron is able to move. One electron is present here, right? And this electron is moving with what velocity? Drift velocity, right? Drift speed or drift velocity, right? And in dt time, right? In dt time, this electron is able to travel how much distance? Vdt. Yes or no? Because you know now, v equals to velocity is equal to displacement by time, right? So displacement is equal to v into t, and here velocity is vd, and I am taking time is how much? dt time. So the electron which is present on this area is able to move by what length? This length, right? So in dt time, the electron which was present here moves to this one, right? So now your electron is reached to the electron which was present here now came to this area. Yes or no? So in vdt time, this one is came to this one, right? Now you can see here. Suppose this is the last electron in this area. suppose I am going to talk about only this area, right? So this volume, suppose I am going to talk about this volume, right? So this, the electron which is present here was the last electron, right? Was the last electron in this volume, only in this volume, right? So suppose this electron is moved to this place, right? So all the electron which is present in this area also able to cross this area, yes or no? This is the last one, right? So this, the electron which is present here, suppose right now I'm talking about this area, okay? Only this area, right? In this area electron is present, right? So the electron which is present here was the last electron, right? In dt time this electron is able to move with what length? This length, right? If this electron is able to move with this length, right? This was the last electron. If this electron is able to move here, all the electron which is present here is able to cross this area, yes or no? So that means the electron which is present here is cross this area, yes or no? So how much electron, how many number of electron is crossed this area? The volume, the number of electron, the volume of the number of electron present in this volume, right? I know this is somehow difficult, but you try to understand. So see, first you think like this. This is your area, right? And on this area electron is present, right? And current is flowing through this conductor, so electron is moving with drift velocity, right? And the electron which is present here is able to move in dt time with what length? B dt length, right? So if this electron is able to move and came to here, so the electron which is present in this region is able to cross this region, this area, yes or no, right? Because this one is crossed, this one is came to here, that means all the electron which is present in this region is crossed to this area, right? So number of electron passing in time dt to this one, number of electron passing this area in dt time is how much? Number of electron in length b dt, right? Okay, number of electron in length b dt, okay? So number of electron, how much is number of electron, right? You know, number of electron in per unit volume is how much? Number of electron in per unit volume is 10. And this is having how much volume? Length is given and area is known to you, right? So number of electron present in this one will be how much? Na Bt dt. So now you can see this number of electron is B dt. Okay. Now you can see this number of electron is crossed to this area, right? So as electron is crossing, that means some charge is crossing to this area, right? And that charge is how much? So amount of charge flowing in time dt, in time dt from any cross section area, right, is dq, yes or no, right? And that dq will be how much? This is your number of electron calculated. This number of electron is crossing, right, in dt time, right? And so if this number of electron is crossing, all electron is having charge, right? And each electron is having how much charge? E, right? So E into this value will give you charge, right? So 10 A B D dt, right? So now this number of this much amount of charge is crossed to this area, right? So now if charge is known to you, right? And so dividing with time you are able to get current, okay? So hence electric current passing through any cross section, right? Hence electric current passing through any cross section is I, right? And that I will be dq by dt, and dq is this much, right? So E N A B D dt divided by dt, okay? This dt cancel, right? This dt cancel. So what value you got? You got I is equal to N E A B D. So this is your relation between, drift velocity and electric current, right? So this is current, this is your drift velocity, this is cross section area, right? And E is the charge on an electron, right? And N is the number of electron in per unit volume, right? So this is all about your relation between electric current and drift velocity or drift speed, both is same, right? Sometimes we call it drift velocity and sometimes drift speed, right? So no need to confuse with these things, okay? Both is same. So this is your relation between drift velocity as well as electric current, okay? So next I'm going to take one numerical problem on this formula, right? So I have written question already, right? So note it down and then I will solve this question with the help of this formula, right? Okay, so you have written all these things, right? So now I am going to solve this question, right? So to solve this question I have to rub this part. Okay, so now you can see here what we have to find drift speed, right? Drift speed we have to find, right? And what value is given? See, area is given here, right? Area is given and density is given. Density of what? Density of copper is given, and one more thing is atomic weight is given, right? And current is also given, right? So these are the data which is given in the question, right? And what we have to find? We have to find drift speed. This one we have to find, okay? This one we have to find, right? So you know the formula. What is the formula of? Just I calculate I is equal to NEAPD. This is your formula, right? And here we have to find drift speed, right? Drift speed is VD, right? So from here we can write VD is equal to I by NEA. Yes or no? Right? So but there is a problem here. Area is known to us, right? Okay? And charge on one electron, this is also known to you, right? But what is N? N is the number of electron in per unit volume, right? N is the number of electron in per unit volume. That things we have to calculate, right? Okay? Number of electron in per unit volume, right? You can see here you can see here, assume that each roughly one electron, right? Okay, so in this question they are saying that each atom of copper is contributing one electron, right? Okay, so suppose we want to calculate what? We have to find number of electron in per unit volume, right? We have to calculate number of electron in per unit volume, right? So number of electron per unit volume, to calculate number of electron per unit volume, we have to find number of atom in per unit volume, right? Number of atom in per unit volume. Why we are calculating number of atom per unit volume? Because they are saying that number of each electron is contributing one electron, right? So number of electron in per unit volume is known, then number of atom in per unit volume is known, then we are able to calculate number of electron in per unit volume, right? Because each atom is contributing one electron, right? Okay, each atom is contributing one electron, right? And we want to calculate number of electron in per unit volume, right? And number of electron in per unit volume will be the number of atom in per unit volume, right? Yes. Okay, so next I am going to calculate this one, right? N. Okay, so N is what? N is the number of electron in N is number of electron in per unit volume is equal to number of atom in per unit volume, and number of atom in per unit volume we have to find. Okay, number of atom in per unit volume. To calculate number of atom in per unit volume, what we have to do? We have to find number of atom, right? Okay, and by dividing with volume we can get number of atom in per unit volume, right? Okay, so first we have to calculate number of atom, right? Number of atom, yes or no? So number of atom, but number of atom we can calculate like this. Suppose M is the mass of copper, right? And Suppose capital M is the molecular weight of copper, right? So mass divided by molecular weight, what will give? Mole, right? And mole multiplied by Avogadro number, you will get number of atom, right? And if you will divide number of atom with volume, you will get number of atoms in per unit volume, right? This is what, this one is giving what? Number of atom in per unit volume, right? So now further you see, I am going to do something, okay? See here, this is your mass, right? Mass by volume we can write like this, mass by volume. Then what value you have? You have Na by M. This M is what? Molecular or atomic weight of copper, right? This M is atomic weight of copper, right? So this is atomic weight, right? So mass divided by atomic weight will give mole, right? Okay, and mole multiplied by Avogadro number, right? Avogadro number will give number of atom, right? And number of atom divided by volume, right, will give number of atom in per unit volume, right? And number of atom in per unit volume will be the number of electron in per unit volume. Yes? Okay. So see, further we can write here M by V is density, right? M by V is density, that is rho, right? So now what formula is given? Na, right? Rho is density, right? And density is given in the question, right? So we can substitute here value. We can substitute here value 9 into 10 to the power 3, right? And to Avogadro number is 6 into 10 to the power 23 I am taking, okay? Divided by atomic weight, right? Atomic weight is how much? Atomic weight is 63 point. Okay, so this value is 63.5, right? And this 63.5 is given in gram, so we have to convert it to kg, right? So convert it to kg, we have to multiply with 10 to the power minus 3, right? Why we are converting into kg? Because your density is given in kg per meter cube, right? So that's why we have to convert it to this one in kg per meter cube, right? So if you are going to solve it, you will get 8.5 into 10 to the power 28, right? So this is your number of electron per unit volume, right? And number of electron per unit volume is represented by n, and so you got value of n, and that, so now you have value of n, right? E is already known to you, right? And A is the area that is given in the question, right? So by substituting all the value in this formula, we are able to get the answer, right? So now I am writing here Vd is equal to I is how much? 1 ampere, right? So I is 1 ampere, N is 8.5 into 10 to the power 28, okay? And next we have to find E is the charge on one electron, right? And charge on one electron is 1.6 into 10 to the power minus 19, okay? And area is also given in the question, and that is how much? 10 to the power minus 7, right? This is 8, okay? So if you are going to solve it, so you will get the value 7.35 into 10 to the power minus 4, right? And this is what? This is your drift velocity, right? And unit of velocity is meter per second, right? So this is your final answer, okay? So we have calculated what? Drift speed, right? So this way, if current is given or drift velocity is given, right? So with the help of other quantity, you are able to calculate value of unknown quantity, right? So this is all about today, okay? So in next class, we will discuss some more things related to this one, okay? So that's all for today.